Okay, so in this video, we want to find a given indefinite integral with the help of a trigonometric substitution as it is required. As we have 1 over the square root of a quadratic polynomial, the first step is the elimination of the linear term using completion of the squares. It's not hard to see to get an x squared minus 2x, that we have to square x minus 1. If you square this, you'll get x squared minus x minus 2x, plus of course 1. We want to get 0, so we subtract 1 from 1 and we get 0. And now you look and you say, okay, well, what is then our trigonometric substitution? We have something squared minus 1, and we would like the result to be a perfect square so as to eliminate the square root. Well, if you remember, secant squared minus 1 is tangent squared, which is a perfect square. So here we simply want to replace x minus 1 by secant of theta. We can find our dx by taking the differential on both sides, and so the differential of x minus 1 is dx, as the derivative of x minus 1 is 1, and the differential of secant is of course secant tangent d theta. And now all we're missing is the simplification of our denominator. So we have the square root of x minus 1 squared minus 1, which is replacing x minus 1 by secant gives us secant squared minus 1. But of course, secant squared minus 1 is tangent squared. And the root of tangent squared is of course tangent. And so now we're good to go. The numerator is simply dx, which is secant tangent d theta, over the denominator, which we have just found to be tangent of theta. So now once again we went from the original integral to a trigonometric integral. We can simplify tangent over itself, and so we're left with the integral of secant of theta. Now if you recall, this is one of our special trigonometric integral, and you should remember that this is the ln in absolute value of secant plus tangent. And so now we're done with the integration problem, but it remains to convert our answer back to a function of the original variable, which here is x. And usually this implies constructing a right-angled triangle from the original substitution. But if you look to our initial work, we're kind of lucky, as the two pieces, secant theta and tangent theta, we already have both as functions of x. So here, the construction of a right-angled triangle is not required. So secant of theta as a function of x is simply x minus 1, done, plus tangent of theta, which is the square root of our initial polynomial. You could leave it like this, but it's a little simpler if you just simply ignore the completion of the squares and go back with the original polynomial, that is x squared minus 2x. Plus of course c, and we're done. So always take a second when you're about to convert your function of theta to a function of x to ask yourself, is the construction of the right triangle necessary? If you already have all the pieces, then don't bother with the triangle, just make a direct substitution, and in this way you're done.